I would like to tell a story of how old, as you can see on the left, becomes new, as is on the right. Around the world, millions of people live in seismic hazardous areas, and many lives have been lost, especially in developing countries of low living standard. So our story is not a one-off story. It is happening around the world. In 2014, a Richter scale 6.5 hit an area in southwest China. It destroyed most of the villages' mud houses. Poor transport and also remoteness means that it is almost impossible to rebuild without using the destroyed ore on site. And by the way, UN statistics has said that over 100 million people around the world still live in mud houses. We met an old couple, and this was their home after the earthquake. The old lady told me, "We are old now and we can die in our tent." The earthquake destroyed houses. It also destroyed hopes and lives. It is what life is worth. I don't think so, and we set to work. Our motto has always been high science and low technology. We have a number of visions apart from making the house safe. The most important of all is to add to life. We must rebuild hope, and life must continue. Villagers have been living in their traditionally built earth houses for hundreds of years. This is their tradition and their heritage, and we wish not to neglect or deviate from this fundamental. And this provides a start of our journey. We talk to the local to understand their needs and wishes. To rebuild life, you must work with people. And based on our understanding of the scientific principles of anti-seismic design, we dissect their traditional houses to identify problems and weaknesses. We examine the composition of the earth they have. We try to optimize the mix so that it can be stronger and more workable based on our material science understanding. We designed with a simple form, modular layout, and system to improve the building's structural integrity, buildability, and also, more importantly, the spatial usefulness. And watch out for that little gap between the two blocks. We conduct tests to make sure that what we design is strong enough. The mud wall of our latest prototype can withstand scale 7 earthquake, and this meets with the national standard. The house needs to be environmentally sustainable and use very little energy. After all, the lady cannot afford energy. We evaluate the environmental design of the earth house based on the local weather and comfort ranges. And we did a lot of parametric studies to examine the effectiveness of various options and designed systems. We also did cost-performance analysis to determine the right kind of approach and option. After all, we don't have too much money. Apart from the high science that I told you just now, we need low technology, both in terms of construction and social technology. We developed a construction method so that the local villagers can learn the techniques very quickly so that they can build their own houses. They are, after all, only farmers. We organized a workshop for them. For example, we taught them how to prepare the raw material on site using very simple tools and how to make walls with their hands that can stand up. We improved the tools and introduced a modular formwork to ensure high quality and consistent workmanship. We provide on-site technical supervision to make sure that they do what we think is correct. This is Master Yang, and he's our best supervisor at the moment on site. 3 years ago, he was a farmer. We knowledge transfer, and it is very important for our project. The villagers need to know how to cope with life next time when the earthquake comes. These are some pictures of the building on site. The building took 3 months to build by the villagers. As the work progresses, we learned a lot from the villagers. And they know a lot about earth buildings, and they taught us a lot about how the details should work. So the learning is mutual. All in terms of material, technology, and life are now regenerated into new. This is our 36th prototype, and I use the word prototype to signify the fact that our effort is ongoing since 2005. The old lady now enjoyed the semi-outdoor atrium spaces for her handicraft. It is brightly lit, thermally comfortable, structurally safe, and protected from the weather. The old man used the second floor as his workshop for written goods. Life now continues. And we conduct an on-site measurement to verify our design. And in the summer months, when the outside temperature is 30 to 35 degrees, the atrium space is 22 degrees. The old lady can now enjoy the atrium with free and natural air conditioning, so-called. And in the winter, when the outside is -5, the indoor is 15. The cost of the earth house is around half of a similar house made with concrete and brick infill. So the house is affordable. New life started without the banker behind you. And more importantly, our locally driven technique means that the dollar and the skills are now remain in the village. A few of the villagers are now making a living by building earth houses for others. As I have mentioned, the house is a prototype. This is our 36th prototype. And we're now summarizing our learning and drafting a technical code for the local government so that they can regulate it. Once that is done, the dissemination process can go easily. And as I speak, a lot more prototypes are now on site. And since the July issue of the AR, thank you for promoting us, we have inquiries from around the world, from Nepal, Cambodia, Bangladesh, and also as far away as Colombia. We will knowledge transfer what we know. Prototype 36 is ready. One done, 20 are now on site, 100 million to go. Disaster happens, we all work to save life. But more important to me, apart from the house, it is not just a house. We must work our architecture to give life back its dignity. Thank you.
Thank you very much. Ian?
Can you just, thank you very much. Very enthralling story. Can you just mention the last bit of the building, which is the roof, and what that is made of and how that is assembled?
Okay. The roof is actually a pyramid-shaped roof. A pyramid is itself a very strong form to start with. It is at the moment made with steel, but we design it in such a way that even if the wall or two of the wall collapse, if they collapse, the roof will stay on, okay, because it is self-supported as a pyramid. So we designed the roof to cap the whole building. And at the moment, we are experimenting with using bamboo. But bamboo, of course, need a lot of work because they don't last most of the time. So we are still experimenting with the durability and also the jointing method. So the 37th prototype, we will experiment with bamboo, but now it is steel.
And what other things have you learnt about the construction and the design that you'd like to improve? You know you need to improve.
Oh, the two things, actually, at the moment, the material itself, we have already found a very good solution. Now it is time to make sure that we use less concrete for the rain beams, right? Because the rain beams are essential for making the wall stay together. So now we are trying to use other materials to replace concrete as rain beam. The second thing we need to learn is how to open the walls, because every opening is a weakness. So we need to make sure that we have the right kind of proportion and size and position for the opening, so that the wall will be integral as the villagers try to build their houses. So these are two of the many things that we need to improve. The third thing we need to improve is the thermal quality. As I say, in the winter, the indoor is 15 when the outdoor is -5. We hope to improve that to something like 20 with some kind of insulation, but in the mud wall itself. So this is now something that we want to experiment with our next prototypes.
Has there been earthquakes since then that one of your prototypes survived? I mean, was it a, excuse me for that immoral question, but
That part of the world have earthquakes almost every other month. This particular house survived since we built it. We have an earthquake about 6 months ago, and it survived without any crack, where the nearby brick houses all cracked away. So this is the key reason why the government is so keen on our project, because it provides a solution, a much better solution, a cheaper solution too for the neighborhood. So last earthquake was 6.3, so it's a minor earthquake to me.
good. And then the material, the mud or clam, is that available everywhere? I mean, is that local?
Yes.
Is it?
We take out the mud from the ground, or we use the destroyed house. But more importantly, we have to condition the mud. So we have to grade them and to see what it is missing and what to add to improve its strength and workability.
Yeah.
So every site we go, we give the villagers the tool, very simple tool, to grade their mud. And then immediately they know what to add back to the mud. Sometimes you need sand, sometimes you need clay, sometimes you need a bit of stone, and sometimes you need a bit of bamboo. So we actually tell them how to evaluate the mud themselves.
If you say we, that the university is a group of people from the university, who is that?
Yes, 3 universities are now working on this project for more than 10 years now. The Kunming, which is a local university, they talk to the officials much better than we can. We are in Chinese University of Hong Kong, and a group of anti-seismic experts are now in Cambridge. So 3 of us actually work together.
Okay, thanks.
Yeah, I must say, very interesting.
Thank you.
So I suppose your drive is at the end to really use only local materials, or as much
Mostly
as you can.
local material, yes.
So that basically means if you would start these projects in other areas in the world, you would basically restart your research into materials, or not?
No, the science part, the scientific processes are now all ready, okay? So
Yeah.
we know how to grade any earth on Earth.
Yeah.
Okay, so
Any
if you
earth
go to
on Earth.
Colombia,
Oh, that sounds good.
we will grade their earth in 2 days, okay? But more important thing is, apart from the science, which is universal, the important thing is the social technology part. How are we going to put the villagers together to build their home?
Yeah.
As a social intervention. That part is not knowledge transferable easily, but we know the protocol, we know who to talk to start with, and all these other things. So if you say we go to South America, okay, it will take us another, say, a year to sort out the social technology part of
Yeah.
the project.
And
But
what-
science is ready.
And what about the electricity? Is there any plan of using solar panels or any other sustainable energy methods?
Yes, at the moment, we don't use solar panel because, as you know, we conduct a cost performance analysis.
Yes.
At the moment, in rural part of China, it is so poor that it is not cost effective to use a solar panel. But having said that, as we improve and as the situation demand or allow, we will continue to evaluate other technology that will improve the performance. But every time we improve the performance, we increase the cost. So we have to balance the two things as we go.
Yeah. Okay, thank you.
Just one question. The split between in the plan with the atrium, that is a new feature they introduced.
Can you speak louder? I can't.
So the split in the plan, which you call the atrium,
Yeah.
is this something new that you introduced into the building typology?
Yes. As you know, a square form is the strongest form, okay? But it is, spatially speaking, not too useful. So we evaluate the use of the building and incorporate into it, in this case, a small atrium space for the lady. As I speak, we have other projects which kind of deploy the block in a certain way to create these in-between spaces for a bigger family and also for a small village. So it allows us to, at the same time, maintain the structural form and allow us to design spatially for the community in many different ways without too much kind of intervention. So this is the reason why we kind of experiment with this, what we call gap in between buildings for spatial use, basically.
So let me just carry on from Mun's question about how the form causes the locals to have to adapt to living.
Uh,
Because clearly the form in some ways comes first, the program in some ways comes second. So could you speak to that a little bit further?
we don't program the form ourselves. As I told you, we talk to the villagers, and in this case, the old lady, what she normally do during the day. And she like doing needlework. Okay, we need therefore somewhere outdoor, somewhere indoor, somewhere brightly lit for her to do all these things. We also, in another project, speak to three brothers, okay? And they want somewhere to play mahjong, so the space will then change. So we don't dictate the program, we talk to them, but the modular design means that it is very easy to incorporate those social needs as the scale changes or as circumstances changes. And this is our purpose.
Anybody else? Ian? Last question.
There's a suggestion about the height of the box. Can you explain a bit more how you arrived at this height, or whether you do lower versions?
We can easily do up to 2 stories, 3 meters per story, with our scale 7 structural requirement. We have no intention at the moment to build 3 stories because there's no such need for the local villagers. So 2-story is at the moment what we are mostly working on. We try to increase the height of the building a little bit in some circumstances to accommodate their tools. So maybe in future, we will go to about 3 to 4 meters per story. Because sometimes in agriculture situation, they have bigger tools. So this one we will also need to investigate.
Thank you very much. It's a wonderful project.
Thank you.